This is the review guide for Unit 3 quiz. So number one, we've got a polynomial. First thing we have to do, it says to write it in standard form. So for standard form, what we want to do is we want to look at all of the degrees for each of the exponents. So here we've got a 3, a 7. There's no exponent here, so we know that that one's going to go last. And this one's a 2. So what we need to do is we need to go in order of highest to lowest. So the highest is going to be this x to the 7th, so we're going to put this one first. So we get 8x to the 7th power. Next, we're going to look at the exponents again. So 3 is bigger than 2. So that's going to be 9x to the 3rd. Next is the 2. We get to keep its sign with it. So we have to go minus 2x squared. And then the number is always last. In this case, it's a minus 11. So we have minus 11. And the big trick on that one is just to pay attention to the negative signs. Other than that, not too crazy. Next one, what is the leading coefficient? So the nice thing is, since we already have the polynomial in standard form, we can just work off of this. And the leading coefficient is always the first coefficient, which is 8. The degree is, since we're in standard form, it's always the highest, so it'll always be the first exponent that we see. So that's going to be 7. What is the type? Well, it's not really an easy one to say because it's a 7th degree polynomial. So it's not a binomial because that would be second degree. Well, I'm sorry, quadratic. It's not a cubic. So it's a 7th degree polynomial. And that's because we know we've got a 7 right there. So we know it's 7th degree. But it also has a certain quality to it. We've got 1, 2, 3, 4 terms. So for 4 terms, this is going to be a quadnomial. Because again, like I said, we did the binomials. Those were things with 2 terms. We did the trinomials. Those are things with 3 terms. This one's got 4 terms, so it's a quadnomial. Oops, let me get rid of that purple thing. All right, so that's number 1. So for number 2, there's a lot of parts to this, but again, this was kind of like Unit 1, where there's a lot of parts. It doesn't mean I'm going to ask all the parts, but we're still going to go over them all just in case they show up. So it says, we've got our equation here. Part A says let graph the function f. F of x is negative x to the 4th plus 4.25x squared minus 1. So there's not really much that I can do with this one right now. I mean, I know the y-intercept. I know that 0, negative 1 is going to be on this graph. So I can plot that point, but that's about it right now. We've got all these decimals. I guess I could do a quadratic equation, but I think the best plan of action here is going to be to just graph it and kind of see what it looks like. So we've got negative x to the 4th. This is 4.25x squared minus 1. I think that was it. Let me double check. Yep. All right. And so what do we actually need for a graph? Well, all the zeros would be really helpful. So if we look at our zeros, we've got 2, 0.5, positive, negative, and positive, negative 2. So let me plop those on. We've got negative 2 and 2, negative 0.5 and 0.5. And then the other key points we want are going to be all of the turning points. So let's go back and grab all the maxima and minima. So there we go. Ooh, that doesn't look too pleasant. We've got that one. So it's about 1.5, 3.5. All right. So about 1.5 and about 3.5. And then also negative 1.5 and the same. And then that makes sense. We have a negative leading exponent. So it does make sense that we're going to have our end behavior just be negative in both directions. And then let's fill out the rest of it. Again, it was nice because we could kind of see what it looked like on Desmos. But it does say to graph it. So we did make our own graph. And again, what would I be looking for in this case? Well, I'll be looking for the zeros, the y-intercept, and the turning points, and the end behavior. So there's a lot of different things to look out for. But the nice thing is a lot of them are shown over here. So we did part A. We graphed the function f. B says identify all the turning points. Well, we actually found all those already because the turning points are either the maxima or the minima. So we said that that was going to be here, here, and down here. So I remember this one because that was the y-intercept. That one was kind of nice. 0, negative 1. The others were those crazy decimals. So negative 1.458. and 3.516. So again, that would be this point up here. That would be the top point of the graph. Then this is going to be the other turning point over here. And that was positive 1.458, 3.516. So those are the turning points. The x-intercepts, those are all the red points. So that was -2, -0.5, 0.5, and 2. Okay. The y-intercept, that was the black point. That was -1. That one's easy to find because you can just grab it from the end. Whatever number you have on the end is the y-intercept. List any intervals where the function is positive. Well, we're positive, again, if we're above the x-axis. So our answer should be between a couple zeros. So in this case, if we go between -2 and -0.5, we're positive. Oops, got my symbols flip-flop there. And between 0.5 and 2. So we've got this section is positive and this section is positive. So that's positive because that's above the x-axis. This is positive because that's above the x-axis. For part F, list any intervals where the function is negative. Well, definitely over here and over here because the end behavior is negative. So off to the ends are both going to be negative. So it would be -infinity to -2. That's this section. This one all right at the end because we have one more section that's negative, and that's between the two decimals. So we'll union that with -0.5. Oops. To 0.5. And we'll union that again with 2 all the way out to infinity. So those 3 purple sections are all below the x-axis. So those are the negatives. List any intervals where the function is increasing. So now we have to focus on the turning points. So increasing, we're increasing actually from here all the way up till we get to our turning point. So that's going to be from -infinity all the way to -1.458. And again, I'm grabbing that from my number up here. So then turning point, I'd have to go to decreasing until I get to the next turning point. Then I'm increasing again because it's a turning point. That would be that. And then I would turn again to go decreasing. So that other part is going to be the final section. So that's going to be from 0 to 1.458. Because again, here we would be going up. So I mean, my graph's kind of showing a lot of colors on it, but that's nice because we're actually on the last one. And there's no places where this is really flat. So to identify the intervals where we're decreasing, we again are going to go back to the turning points and again follow our turning points for where we're going down instead of up. So that would be all the places we didn't pick last time. So this negative something to 0, so -1.458 to 0. And we're going to union that with 1.458 all the way out to infinity. And then we're all set. So yeah, a lot of parts of that question, but the keys on this one is if we look at what we got, the positive and the negative, those answers all deal with the zeros. So if you look, all of my x-intercepts, those are all the answers that I used for my positive and negative choices. That's all the 2s and the 0.5s. When I'm dealing with increasing and decreasing, that's where I have to deal with my turning points. So again, all my answers came from my turning points, other than the infinities, of course, because that's just the end behavior. But that's what we got for that one. So long question, but it's a lot of vocab, just like with Unit 1. All right, for number 3, use leading coefficient and degree of the polynomial. Function f of x equals -5x to the 5th minus 10x cubed plus 11x plus 15. To determine the end behavior of the graph, select all that apply. So for this one, again, we want to find the leading coefficient, which is negative, and the degree, which is odd. And then we have to think about, okay, well, where on that chart of the 4 things that we looked at is the negative and odd? Well, we know that the odd would be like a straight line, and then a negative is going to flip it. So let's flip that. Up, down. And we can see, oh, okay. So On the left, I should be at positive infinity. On the right, I should be at negative infinity. So select all that apply. So I'm going to pick one of these ones. So as x goes to infinity, I see. So we're kind of flip-flopping here. We got to pay close attention. As x goes to infinity, y is going to negative infinity. So that's B. And I'm picking one of these two. As x goes to negative infinity, y is going to go up. So we're going to pick C also. So it's going to be B and C. So that one, I guess we had to be a little bit careful because it looks like I flip-flopped the answer choices there. So normally we're used to doing the negative infinities first and the positive infinities second, but this one was a little bit flip-flopped. That's okay. You have to be really careful as to how we read the answers. All right. Number 4, it looks like another long one. It says, for this polynomial function, f of x equals x cubed plus 2x squared minus x plus 3. First part says sketch a graph of f of x. So again, we're going to do kind of like we did in the other question. We need all of those zeros and the turning points, and that's going to help us out. So let's do that right now. We got 1, 2, negative 1, 3. 1, 2, negative 1, 3. So that is x 3, 2x squared minus x plus 3. All right, that looks like that's it. Look at my axes. I see I'm going from like about 10 to 10, so I'll probably got to fix that a little bit. So let's go ahead and zoom out. I'll change this to negative 10 to 10. And there's not really much on this graph, which is kind of interesting. So let's see what we've got as our actual points here. So we've got a 0, 3. So that's going to be important. We're going to need that 0, 3. So we'll plot that one. But again, we could have just grabbed that from right here. What else do we have? Here we've got a negative 1.5, 5.6. Is that actually going to show up on our graph? Oops, wrong button. Oh, yeah, that will. So negative 1.5. Get like 5 in a little bit. That in blue because it's a turning point. And then we've got one more turning point down here. 0.215, 2.887. 215, 2.8817. All right, and it does say to sketch a graph, so we know that here we're going to go down. Maybe I can grab the 0. That's all the way at 2.7. I don't know if that's on the graph. Nah, that's going to be kind of far off this way. Well, that's okay. We'll still put it over here. We're going to turn here, and we're going to turn here, and then just kind of go up forever. Again, I don't need to be perfect because it does say to just make a sketch of the graph, and that's going to be fine. I got my turning points, I got my zeros, and I got my y-intercept, so that's going to be pretty good. Oh, I also have my end behavior. End behavior is going to be important as well. So I got my arrows, I got my turning points, my y-intercept, and I do have the 0 on there. So for part B, it says fill in each blank using the code. So each symbol is going to represent a different word. So we have to find out what's going on from negative infinity to negative 1.549 and 0.215 to infinity. So let's see. If we take a look at these intervals, what we want to do is trace it out and see what's happening on these intervals. And 2.5 to infinity. All right, so looking at that, it looks like what's happening on those intervals is it looks like we're increasing because we're going up. So I'm going to fill that in with a nice little circle for increasing. Next, I'll look at the other next interval. So negative 2.757 to infinity. So let's see, negative 2.57 to infinity. Well, that looks like it's almost the whole graph, but it is all above the x-axis. So in this case, this is going to be the one that's positive, and that's what the triangle is. All right. Seems like we're doing pretty good. Next, we look at this interval, negative 1.549, that would be right here, to 2.15. So again, I just want to see what's happening in that interval. And that's going to be the decreasing interval. So we'll put the square for that one. And then there's only one choice left. So negative infinity to negative 2.757 is just this little arrow over here. but that is where we are negative. So we'll put the star right there. So that one gets the star. Try and make my star a little bit nicer, but probably make it look worse. It looks okay. That's a star. And so we've got our 4 options. So it's kind of like it's a matching question where we just have to pick the right word for each section. There we go. So that's it. All right, moving on to number 5. The volume in the water in a tank is modeled by this function, y equals 72.54 x to the third minus 10.16 x squared plus 12, where x is the number of minutes after the faucet filling the tank is turned on. What's the y-intercept of the graph? Don't even need to graph it. It's the number at the end. So it's 12. It'd be nice to put the, we want to put the units on here. So let's see. It's going to be not 12 minutes because the minutes is x. So it's the volume. So it's 12 cubic units, UN cubed. So that could be like a gallons or something. So there we go. And then part B, write at least one sentence describing what the y-intercept represents in the context. So, remember in Mathland, the y value is always what, or the y-intercept is always what the x value is when x is 0. So in this case, if x is 0, this would be 0 minutes. So if you haven't turned the tank on, this is just going to be the amount of water. AMOU, amount of water in the tank before filling. So in this case, we would say we would have 12, and again, this is going to be units cubed of water starts in the tank. So we have the context. So again, remember with context, we need to have like an English sentence describing what we've got. We need to actually say what's happening. And this is the context for this one. It tells us how much we're starting with. And again, we want to talk about both the number and the units because we want to make this a real world question. All right, next we have some polynomial addition. So this is basically combining like terms. So I'm going to go ahead and search. I've got x8 x to the 5th and negative 5x to the 5th. 8 minus 5 is 3. I don't change the exponents. Next exponent I see is I've got a 3, so minus 5x to the 3 plus 7x to the 3 is 2x to the third power. Next, I see I got a 13x and a minus 9x. 13 minus 9 is 4x. And then I still have a number at the end, and that's okay. It's not going to combine with anything else. It's just going to be plus 9 at the end. And that's it. So the goal there is just combine like terms. Multiply. So we're going to multiply. This is a binomial times a trinomial. But again, we can do this just like we did with the last unit. We can say we want 2x times 3x squared minus 2xy plus 4y. And then plus 5y times 3x squared minus 2y plus 2xy plus 4y. That looks like an x. So again, we're just using our double distributive method here. Not super exciting, but it is cool that we get to do it with not just 2 binomials. So we do all the distributing. So this 2x has to go to everything. So x times x squared is x cubed. X times xy is x squared y. 2x times 4y is 8xy. Then I have to distribute this 5y to everything. So we get 15x squared y. And notice I'm always putting the x's before the y's. Again, that's kind of like standard practice. We put the letters in alphabetical order, and it will help when we try and combine like terms. 5 times negative 2 is negative 10xy squared. And then 5y and 4y, that's 20y squared. All right, so now I have to search to see if there's any like terms that I can combine. And there are. Nothing really goes with the x cubes. So next I'm going to look for the x squareds. So here I've got a minus 4x squared y. I've got a 15x squared y. So this is going to be plus 11x squared y's. Next, I'm going to look for, I could do the xy or the xy squared. I'm just going to go with the xy next. So we'll just put plus 8xy. That doesn't combine with anything. Minus 10xy squared. So that's not going to combine with anything. And then at the end, I've got plus 20y squared. And that is it. So it looks like we're done. All right, sounds good. This is kind of cool because not only does it go in decreasing order of x's, but it also goes in increasing order of y's. That's why I put this green y squared second, so that we'd have no y's, y squared, y squared. All right, for number 8, we get to do one of these box questions. So Jay is constructing an open box from a piece of cardboard that is 10 inches wide and 16 inches long. Jay cuts squares of equal size from each corner of the cardboard, then folds up the sides of the box. So he's going to cut out the little squares and then fold that up. So that means that this is going to be the height. So the height is going to be x. So we know that's going to be the height of the box. So it says write a polynomial function v for the volume of the box in terms of x in factored form. So we know that v is equal to length times width times height, because we're going to make a box. That makes sense. So the length is going to be this section. Well, we know that it's 16 inches longer initially, but we're cutting off the two x parts, right? We're cutting x off here and we're cutting x off here. So this is going to be 16 minus 2x. All right, well, we need the width next. So for the width, we're told it's 10 inches wide. But again, we're cutting off x and x on both sections. So it's 10 minus 2x. And then the height has to be next, but the height is just x. So we say x. And that's it. We're actually done at that point because it says write the polynomial function. That's our polynomial function. It's in factored form because it's in the sets of parentheses. So it looks like we're good to go. Kind of cool. And it does tell us how much we can cut. So if we didn't cut anything, we'd have no height. We would be in trouble. If we cut 5 inches, we would have no width. We would be in trouble. If we cut 8 inches, we would have no length. We would be in trouble. So this gives us our ideas of where our problem sections are going to be. Part B says to write the polynomial function in terms of standard form. So we're just going to go ahead and multiply this through. So the nice thing is what we're going to do is multiply 16 minus 2x, 10 minus 2x, and then x. And what we're going to do is just double distribute. So we have to go one at a time. So we'll do 16, 10 minus 2x, minus 2x, 10 minus 2x. So let's go ahead and double distribute. 16 times 10 is 160. 16 times minus 2 is minus 32x. Negative 2 times 10 is negative 20x. Negative 2 times negative 2 is 4x squared. Now this is still got that x on the last side. So we're not done yet. I'm actually going to distribute before I combine like terms. And the only reason for that is I think it's going to be really easy to just add one more x onto all of these things. So I'm actually going to distribute this x through first. You could combine like terms first if you want. I just feel like I want to do this today. 160x minus 32x squared minus 20x squared plus 4x cubed. And now we combine our like terms. 160x minus 52x squared plus 4x cubed. Now we're not quite done because we've got everything multiplied, but it does say we have to put it in standard form, which means these x cubes have to be first, then the x squareds, then the 160x. And so this is going to be our final volume. And so that's going to be our result. I want to make sure that it's equal to v. because we do want a polynomial function. So let me just have all of these equal to v as we go. But we do want to make sure that our final answer is actually a function. If you just write an expression is not really a function, so not really right. So you have to make sure that it's equal to the volume there. All right, for number 9, it says the volume of a hemisphere with radius x is 2/3 pi x cubed. Volume of a cube with height of x is shown in the graph. When x equals 4, which volume is greater? Circle your choice. So it's really a 50-50. So when we've got an x equals 4, I guess my face is kind of hiding the 4 right here, but it looks like if we checked out what we had, we're between 60 and 70. All right, well, when x equals 4, if we plug this into the hemisphere equation, so for the cube, again, we're between 60 and 70. For the hemisphere equation, this is going to be 2/3 pi 4 to the 3rd power. Okay. Well, we got to figure this out. Why don't we just throw it into Desmos? I think that might be the easiest thing to do. I mean, we can kind of look at that and solve it just by staring at it, but just so we can all see where that's coming from, 4 to the 3rd power. We get 134. So this is not an equal sign. That's about 134. The reason I don't really need any decimals with that is if I'm comparing 134 to 60 to 70, I think I can tell that this one, the blue one, is going to be bigger than the black one. So we're going to pick the hemisphere. And again, we figured that out because 134 is going to be greater than 60 to 70. So the actual volume of the cube, again, you might know that formula is it's going to be x to the 3rd power, 64. So you know that you actually know that this is 64. Cool. So that's it with number 9. Just do some calculations and read the graph. For 10, it says complete the proof of this identity. So I gave you a couple things just to make it look a little bit more reasonable to do. Kind of looks like a geometry proof. So I gave you all the reasons, so you just have to kind of follow through and do the operations correctly. So the first thing says we're given this statement. Next, we need to distribute 8x, x to the 8th power minus y to the 12th power over x to the 16th plus 8x to the 8th, y to the 12th plus y to the 24th. And again, that means what we're going to do is distribute this way. Now, when we say distribute over, that means this is just going to be what we do at first. We're just going to write it kind of like we normally do. Plus y to the 24th. And then minus y12. Oops. I might need a little bit more space, but that's okay. y12 plus y24. All right, so we've distributed that over itself. The next step says to distribute, so I actually have to distribute everything. So this is going to be, and again, you have to write everything out because we're trying to prove it. We're not trying to show it. So x to the 24th plus x to the 16, y to the 12, plus x to the 8, y to the 24. And we have to distribute this y to the 12 to all 3 pieces. So minus y to the 12. Well, let me put this in standard form. Let me put the x's first. So x to the 16, y to the 12, minus x to the 8, y to the 24, minus y to the 36. All right, and then it says combine like terms, and we can double check. So again, we don't have to do anything here, but if we double check, this is going to cancel with this term, and this is going to cancel with this term, so it does work out. All right, well, I see there's a typo in this one. So let me just fix this real quick. That should be a 9x. Because it says use polynomial identities to multiply these two things together. So 9x minus 2y squared times 9x plus 2y squared. So the whole idea here is I don't give you a lot of space. So we're not actually going to multiply with the double distributive property. We're just going to recognize this is going to end up being in the form of a squared minus b squared. So what I want to do is square 9x. 9 times 9 is 81. I want to square 2y squared. So 2 squared is 4. Y squared squared is y to the fourth. And I just want to get out of there. That's all I want to do. So I'm literally just squaring each of those two terms. Again, a little bit slower. 9x squared is 81x squared. And then 2y squared is 4y. 2y squared squared is 4y to the fourth power. Just like we had last unit, it's one of those tricks that we had, just like when we were working with the i's. In this case, this is the trick that we want to use, and that's it. Again, we got polynomial identities. We want to factor. We only have two things. We can see we can't take a square root of 27, so it's not going to be a minus b, a plus b. But we can do a cube root. So cube root of 27 is 3. And we can also do a cube root of this one. So cube root of 8n to the 6th power is 2, and then 6 divided by 3 would be n to the 2nd power. So since I can take the cube root of both of them, I can use one of the cube root forms. I can use either the sum of cubes or the difference of cubes. X minus y, since we're doing a difference of cubes in this case, x squared plus xy plus y squared. So we've got as our answer 3 minus 2n squared, and then 3 squared plus 3 times 2n squared plus 2n squared squared, which is going to become 3 minus 2n squared. 3 squared is 9. 3 times 2 is 6. And then 2 squared is 4. N squared squared is n to the fourth power. Now we don't want to multiply all this through again, because if we did, we would get back to where we started with. And we could see that that's going to work, right? 9 times 3 is 27. Minus 2n squared times 4n to the fourth is negative 8n to the sixth. And then our middle term should cancel out. 3 times 6 is 18. Negative 2 times 9 is 18. 3 times 4 is 12. Negative 2 times 6 is negative 12. So those would all cancel out, and that does get us back to where we started if we wanted to multiply through. But again, point isn't to go very, very deep on this one. It's to get it very quickly. So that's the answer. For 13, use Pascal's triangle to evaluate this expression, x plus 4 to the 8th power. So what we need to do is use Pascal's triangle. We're going to go down to number 8, since we're going to the 8th power here. And these are going to be all of our leading coefficients. So that's going to be a long question, I think. Not in terms of difficulty, just in terms of writing. So what I need to do is I need to take this 1 from Pascal's triangle. And then my a term in this case is going to be x. So x to the 8th. And then my b term in this case is 4. So times 4 to the 0th power. And so every time, what I'm going to do is I'm going to go across my row on my Pascal's triangle for the black number. So the next one is 8. I'm going to decrease the blue one by 1. So we get, instead of x to the 8th, we get x to the 7th. And instead of 4 to the 0, we get 4 to the first power. So the red ones keep going up by 1, and the blue ones keep going down by 1. And that's kind of the pattern for this whole thing. But we do need 28. So plus 28 x to the 6th times 4 to the 2nd. All right, what's next in my row? 56. All right, x to the 5th, 4 to the 3rd. Thought 70 was next. Yep, 70 is next. All right, x to the fourth, 4 to the fourth. All right, and the cool thing about the triangle is that it is symmetric. So I know that the next number has to be 56 again. X to the third times 4 to the fifth. And then symmetric, so 28. X squared. Oop, not y. We have a number this time, even though 4 kind of looks like y. 4 to the sixth. And then 8 is going to be next. X to the first power. 4 to the seventh power. And then lastly, we get 1. X to the 0 power. Barely fit it all in there. 4 to the 8th power. And again, as you're writing it, remember the 0 powers you don't really need to write because they're just 1. But I put that up there just so you can see, okay, yeah, it is starting at 8 and then going all the way down to 0. And then the b term, in this case 4, is starting with an exponent of 0 and going all the way up to 8. That's how the triangle works. Now we're not done because we still need to simplify this. But when we simplify it, we're just trying to multiply everything we can. So in the first case, we can't really, this is just going to be 1. 4 to the 0 power is 1, and 1 times 1 is 1. So the first term is just going to be x to the 8th power. I'm going to switch colors as we go. I'm not going to use all different colors, I think, but we'll switch as we go. 4 to the first power is 4, and then 4 times 8 is 32. Okay. And then now is where we might need a calculator for this. So we've got 4 to the second power. I know that's 16, but 16 times 28, I think I'm just going to defer to my calculator in this case. So bring this up. And 16 times 28 is 448. So we get 448 x to the 7th. Oop, not x to the 7th, x to the 6th. We're on this one. So again, our 4 squared gets used because we multiplied 28 times 4 squared, 28 times 16. So then for the next one, I got 56 times 4 cubed. Well, I know 4 cubed is 64, but let's just put it in as a cube just to see what it looks like. 56 times 4 to the third power is 3584. All right. And again, we've got x to the 5th here. All right, well, next one we've got 70 times 4 to the 4th power. Okay, 70 times 4 to the 4th power is 17,920. And then we got x to the 4th. All right. 56 times 4 to the 5th power. Okay, 57344. X cubed. 4 to the 6th times 28. One 688. X squared. All right, and then we've got 8 times 4 to the 7th power. One 072. And lastly, at the very end, we've got a 4 to the 8th power, because x to the 0 is just going to be 1. So we have to do 4 to the 8th power. 65536. And that's it. That's the final result. So it's a big expression, but it's all done. This one was nice because it was a plus. So we didn't have to deal with any negative signs. Remember, if there are negative signs, anytime you have these odd powers, then you're going to end up with a negative sign from that. So that's one thing that you got to watch out for, is that the odd powers could end up being negative. So there we go. And again, it's the odd powers of the number, not of the x's, which in this case, they were kind of the same, but odd powers for the numbers. So cool. That's 13. And last one, again, we have to use the binomial theorem again, and this time we do have a negative, so we do have to watch out. But we're using the same idea. So we're going down to Pascal's triangle. We see we've got a sixth power, so we're going to pick this row here that's got the sixes in it. And we're just going to go ahead and throw them in. So just like we did last time, it's going to be 1 2a to the 6th, negative 5 to the 0th, plus 6 2a to the 5th, because we bring the blue ones down, and reds go up. So negative 5 to the 1st. Okay. 15 is next. All right. 2a to the 4th, negative 5 squared. 20 is next in the row. Bring the blue ones down. 2a to the 3rd, negative 5 to the 3rd. Red ones go up by 1. All right, and then 15, 2a squared, negative 5 to the 4th. Then we get 6, 2a to the 1st, negative 5 to the 5th. Well, that didn't quite fit this time. Plus 1, 2a to the 0, negative 5 to the 6th. So just another big expression. But the cool thing with this is we have the triangle there to help us out. So now we need to simplify. So this one's a little bit trickier than the last one, because now we've got 2a to the 6th, which means it's going to be 1 times 2 to the 6th times negative 5 to the 0th. So again, I'm going to throw that in just so we can see what that looks like. Let's say we've got the black 1, we've got the blue negative 2, and then we've got the red negative 5. This is positive 2. Negative 5 to the 0th power. So I'm going to put that in there. Now, the only reason I'm doing it for the first one is I want to set it up so that I don't really have to change much for all the other calculations. So I get 64. 64 is my number. So I've got 64, and then I've got a to the 6th. All right, so for the next one then, now I just get to change 1 to 6, and then I change my exponents. So from the triangle, I'm going to go 1 to 6. This exponent goes down 1. This exponent goes up 1. And so I get negative 960. And so we said, oh, not going to get a plus here. We're going to get minus 960, and then a to the 5th. So again, we want to be really careful with the negative signs. All right, well, 15 is the next number, so let's put a 15 in there. 2 to the 4th, negative 5 squared is 6,000. That's nice. 6,000 is a good number. And then a, we're on this one here, a to the 4th. All right, 20 is the next number. Down to 3, up to 3, so we're going to subtract 20,000. A to the 3rd power. All right, so we kind of turned our corner because now we see these two are the same. So we're back to 15 again. So 15. B down to 2. This 3 goes up to 4, 375, 00. OA squared. All right, and then we got 6, then 1 and 5, so we got 6. Very methodically, this one goes down 1, this one goes up 1. So negative 37500. Well, that's kind of cool. We got the same number for both of those. And then the last one, we go all the way back down to 1. This one gets reduced to 0, and this one gets bumped up to 6. So 15,625. Whoops. Hit my little button on my pen. And so that's it. So that's our final answer for that one. So again, takes a little bit of time, but you just want to be really careful and do the bookkeeping correctly. So that's everything on the guide. So that's it.